Hey, how are you doing? This is going to be a video, I'll keep it as short as possible, concerning the three factors that give us our tides. Okay, the three factors that cause our tides are factor one, magnetic field, which we have to the north, factor two, electric charge, which happens because of the magnetic field and also feeds back to the magnetic field, and factor three, convection currents. So we have factor one, magnetic field, factor two, electric charge, factor three, convection currents. Okay, the one factor that does not cause our tides is gravity. That does not happen. Okay, a quick definition here. Paramagnetism and diamagnetism. Atoms with unpaired electrons are called paramagnetic. Paramagnetic atoms are attracted to a magnet. Atoms with paired electrons are called diamagnetic. Diamagnetic atoms are repelled by a magnet. So material or substance that's paramagnetic will be attracted to a magnetic field. A material or substance that is diamagnetic will be repelled by a magnetic field. Okay. Now, so salt water. How salt water affects magnets. I'm going to just read out these parts here. Have you ever wondered what happens to a magnet when it's used near or fully immersed in salt water? First, you might consider that you know what you know. Sorry. First, you might consider what you know about the relationship between magnets and fresh water, which is considered slightly diamagnetic. This means it creates a weak oppositional magnetic field to an applied magnetic field. However, if you add salt to the mix, the water's magnetic field completely ceases to have any significant impact on other magnetic fields. Salt also lowers the boiling point, raises the freezing point, and strengthens water's electrical conductivity. This means salt water affects magnets differently than fresh water. Salt water and electromagnets. Salt water conducts electricity more efficiently than fresh water, and its conductive properties create a moving magnetic field when an electromagnet is placed nearby. Then the salt water creates an opposing magnetic field, causing turbulence, erratic changes in pressure and flow velocity in the water. When a charged magnet comes into contact with salt water, the ions flow through the metal to become stabilized, resulting in the electrical field. Okay, so a magnetic field has a much more turbulent effect on salt water than it does on fresh water. Fresh water is diamagnetic, but salt water has a different effect where it causes turbulence within it because the salt is a very good conductor of electricity. Now, just to show some, sorry, not this one, videos. Now, in this video, I'm going to show here, I'm going to show mercury, liquid mercury. Mercury is also diamagnetic, and mercury becomes mildly magnetic when there is a DC current run through it. Here, this man has a DC current running through this unit, and in the well of the unit here, he has liquid mercury. Now, he's about to place in a magnet, positive side up. Okay, and I'm going to show you what happens. Okay, as you can see, it causes the mercury, because the mercury has been made magnetic, mildly magnetic by the DC current. It causes then the mercury to want to move away from the electric field, and when it's red side up, it moves in a clockwise formation here. And now he's going to take it out and he's going to switch it to the green side, the negative. I'm pretty sure red is positive and green is negative. And now watch. It'll move away the opposite direction. So it wants to go the opposite way now. Okay, so this is what happens when when a liquid is diamagnetic. Okay, here we have a magnet placed into a saucer of water, and watch the turbulence that's happening in the water. And this is just fresh water, this is not salted water. As you can see, there's turbulence happening in there. And the man is, but the person who has it is going to take out the magnet now in a moment and show that it'll be still afterwards. Okay, so the water went still once the magnet was taken out. When the magnet was in there, though, it was causing turbulence within the water. Now, this is going to show a magnetic field. This here is water in a little plastic tube, and it's placed into this flotation, this like sponge, black sponge, and this whole apparatus then is placed onto a plastic container of water, and this is going to show how just fresh water is repelled by a magnet. It was floating in that direction, and now with use of the magnets, it's starting to push away. Without the magnets touching off it, it's pushing away from the magnets, and that's the water within the tube that's doing that. I'll go back the other way now. It's pushing it back the other way. Even though there's been a flow caused by the fact it went over from left to right, it's still, because it won't go near the magnet, it pushes back against it as it creates a magnetic field of its own against the magnet. Okay, now so electric whirlpool, this is like just something that anyone can do, right? This is from a branch of science known as Magnetohydrodynamics. Okay, magnetohydrodynamics is the reason you have such things as gyro compasses and a railgun. That's due to magnetohydrodynamics. Okay, for this they used an AA or C battery, 2 pieces of wire, plastic cup of water, preferably clear for better viewing, 1 disc magnet. It's a neodymium magnet is recommended. Salt, pepper, and tape. Okay, so first of all, they dissolve salt into the water. Then they place the cup of salted water onto the magnet. They add pepper then, so they can. The pepper is used as so you can view the water churning easier. Then they take the 2 pieces of wire and they tape them to either end of a battery. Then they put the apparatus into the water with one of the pieces of wire pointed towards the center and the other one against the side. Okay, maybe they tape it on or whatever. Now what this causes is a magnetic field coming up the way, and there is an electric charge. Now a magnetic field will create an electric charge, and a moving electric charge will create a magnetic field. So they work hand in hand. They kind of help each other out. So there is an electric current from the battery interacting with a magnetic field coming up from underneath, and the magnetic field is creating another electric charge. And what this does, because of the salt is a good conductor of electricity, it causes the salt water to start to move. So it starts to swirl, basically. It causes it to move and swirl like a whirlpool or whatever, to move around. Now, that amount of electricity and magnetic field, there would be more than we would have in our world in comparison to the oceans. But the point of the matter is that magnetic field and electric current interacting with salt water will cause movement within the water, and it will cause the water to move in whatever particular direction. What our magnetic north is, whether it has a positive and negative right there, or it's a positive or negative and there's another positive or negative somewhere else. I have my own theories on that, but I'm not going to go into that. This is just showing what happens with salt water for the moment. So here I'm going to show, right, salt water, right. This is a plastic cup, has salt water in here in the cup. There's a magnet placed in the cup. This is a piece of plastic, just cut from another cup, placed into it. And now the person is going to, they took this bulb, they wrapped some copper wire around the end of it, right? And now they're going to put this bulb into the salt water. Okay, now the salt in this water wasn't dissolved, it was just put in, so it's sitting at the bottom. So they're just showing the conductivity of it. Okay, and it lights the bulb. Okay, so salt water with a magnetic field and electric charge will light a bulb. It creates energy basically. Okay, now so we've established that salt water, okay, salt water will become is more turbulent. Sorry, that a magnetic field has a more turbulent effect on salt water than it does on fresh water. It causes more turbulence within the water because the salt within the water is such a good conductor of electricity. A magnetic field will create an electric charge. A moving electric charge will create a magnetic field. So what happens with the salt water is there is a moving electric charge happens because the water is diamagnetic, and with the salt having an being such a good conductor of electricity, what you end up with is the water moving, which is a moving electric charge, creating an opposing magnetic field. So what's happening is you have a situation where you have a lot of turbulence going on within salt water because of electricity and the water being diamagnetic. So now, but there's another factor, right? Convection, right? Due to our sun. Our sun creates convection currents within our oceans. If you look at the oceans, and the biggest amount of flow is always going to be around between the Tropic of Capricorn and the Tropic of Cancer. The most amount of flow will be happening, and changes will not so much tide heights, but will be happening in movement, will be happening there. And the reason that is because that's where our sun is moving around. The sun is always between the Tropic of Capricorn and the Tropic of Cancer. It moves across and back over the equator to go, and it stops when it's in the southern summer. It stops. It doesn't go any further than the Tropic of Capricorn, and in the northern summer, it doesn't go any further than the Tropic of Cancer. 21st of December, it's going around the Tropic of Capricorn, and the 21st of June is going around the Tropic of Cancer. So, right. So the sun is creating convection within the water. Convection is when hot and cold, when heat creates heat changes the density of water. What happens is that there's an exchange happens between the less dense warmer water and the more dense colder water. So this is showing convection here. So this person has 3 mugs, and the one in the middle has hot water in it. So you're going to watch what happens. And they have food dye put into this container here. So watch what happens here. You're going to see it move around. The heat is causing convection. So there's a replacement going on. So the less dense will replace as it rises, is pushing down the colder water at the top, and that comes down, that heats up, and that comes up and pushes back down. So it's like a complete cycle. Convection is a cycle, convection currents. So you can see what's happening here. That's what's happening in our oceans. It's just happening at such a bigger scale. It's not as obvious, but it's happening at a bigger scale. So you can see it there. Now, much faster. There you go. You can see what's happening. So that's the kind of effect that's happening in our atmosphere. But you have the sun moving, so it's not just in one place like this cup. So if you imagine this is inverted, I'm just going to go back to that bit because that was very good. So if you can, go back again. So if you can imagine the sun here causing this effect, let's say it's inverted, and this is the bottom of the ocean, this is the top, right, and this is the sun. So if you move the sun around, it's creating convection within the oceans. So what's happening is it's causing this exchange to happen. So look at the exchange 10 times faster. You can see the exchange happening. This is what's happening. Okay, so that's convection, which causes movement. So you have convection, you have magnetic field, and you have electric charge. and you have salt water. So that's what's causing the tides. This is the reason. I'm just going to read this one more time. Salt water and electromagnets. Salt water conducts electricity more efficiently than salt water, and its conductive properties create a moving magnetic field when an electromagnet is placed nearby. Then the salt water creates an opposing magnetic field, causing turbulence, erratic changes in pressure, and flow velocity. And pressure, also you have to remember, changes in pressure will also cause movement. Change in pressure will also cause temperatures. Velocity in the water. When a charged magnet comes into contact with salt water, the ions flow through the metal to become stabilized, resulting in the electric field. Okay. Now, things we know. Sorry, just going to move this down. Now, things we know. Sorry. 1. Paramagnetism is defined as something that is attracted to a magnetic field. Okay, we know this, right? Diamagnetism is defined as something that is repelled by a magnetic field. We know that. So we know paramagnetism is an attraction. Diamagnetism is a repellent. Okay, a magnetic field generates an electric charge. This is true. A magnetic field will always create an electric charge. A moving electric charge will create a magnetic field, right? So a moving electric charge will create a magnetic field, just like, right? The salt water becomes, a moving electric charge, and that creates an opposing electric field, okay? Salt is a very good conductor of electricity. That's the reason. It's the conduction of the electricity because of the salt. So that is such a massive part of why our oceans do what they do. Water is diamagnetic, so it is repelled by a magnetic field. We know this. Water is repelled. It's just been shown. This is what happens. Salt water has a much more turbulent effect. A magnetic field we know has a much more turbulent effect on salt water. Magnetic fields and electric charge have a more turbulent effect on salt water than they have on fresh water. As I just said, this is a true thing. All the evidence you need is there. This is not something made up. It's no magic effect from space or any other unreal medium. The highest tides we experience are always north of the equator. The lowest tides we experience are always south of the equator. This is a fact. North of the equator, you get the highest tides. Right? I've lived in the southern hemisphere. Right? I lived in Australia, and I've been to this southern hemisphere, past the equator, several times to different countries, and the tides are hardly noticeable. Now I'm from Ireland, and the tides are the tide here is very high and very low. It can come way in, and you can't ignore it. It has to be taken into account no matter what you're doing on the water, whether it's going for a swim to going out in a boat, anything fishing. You have to take the tides into account because when they change so drastically. And unfortunately, it even kills people when they get trapped by the tide. In Australia, one thing I noticed was there was hardly any tide change, because there was a tidal change, but it was so minimal that it wasn't noticeable. Now, the thing about it is, the highest tides we experience are in the north. What else is in the north? The magnetic field. So we have a magnetic field in the north, right, emanating from the north, right, and it does appear to move a bit around. Don't buy into the whole magnetic declination thing, as that involves an angle taken off of what they call true north, which is just where all the longitude lines meet in the north of the globe. It's a globe thing. It's got to do with longitude and latitude. It's not a real place. It has no relevance. So anyone who speaks about true north really should be only speaking about magnetic north, because that's the only true north. The magnetic field in the north does appear to move around a bit, but I have a feeling that's to do with the tides having an effect on it, and the sun and the moon. There's more going on there than we know, but rather than speculating, what we do know is we do have a magnetic field to the north. We also have the highest tides we experience are always in the north, and the lowest tides we experience are always south of the equator. So north of the equator, the highest tides; south of the equator, the lowest tides. Now it's correlative, but we can show with demonstration that the correlation could very easily be the cause. Okay. So freshwater lakes have only a fraction of the tidal effect that the saltwater oceans do. So freshwater lakes have hardly any tidal issues at all. Like the Great Lakes in the northern USA, they have at the highest spring tides they have is like a 5 centimeter change, something like that. So they are affected by the magnetic field, but not to the point where they have turbulent high and low tides. Okay, so yes, fresh water is affected by the magnetic field, but it doesn't have the same effect on it as it does have on salt water. So that's why we have a difference in tides in lakes as opposed to oceans. Because the whole nonsense about gravity never ever explained that. It was always like a total contradiction, and it was always total doublespeak concerning gravity. And this is going back to what we were taught about gravity, which is that it's a mass attracting a mass nonsense, whereas that's actually out of date. That's not even current science view that as out of date, which we will get to. Okay, saltwater lakes like Utah's Great Salt Lake or the Dead Sea, which is actually a lake, have easily 10 times the salinity of the oceans, and they have more evaporation of water than they have water feeding into them by adjoining rivers for large portions of the year. Okay, so so Utah's Great Salt Lake and the Dead Sea, lakes like this have a lot of salt in them. They don't have a huge amount of water in them, but they have massive density because of the salt. So technically, they're in the middle of a phase change because they're kind of leaving the water, the liquid phase, and going back to the solid phase. That's kind of what's happening. They're in the middle of the solid and the liquid phase because the amount of salt that's within the water and the small amount of water that's there. So people often go to these places and they float and they get a lot of health benefits from the salt and all that, but they're not places that are all year round, have a huge amount of depth. I did read about. I was trying to find some information about the tides in those lakes, and the one lake I did find tidal information about was in a saltwater lake in Alaska, and they will have like in September, coming in the next few days or whatever, they'll have a 1.5 meter tide in this lake. But I don't know. I couldn't find whether the lake was being fed by fresh water or salt water, freshwater rivers or salt water from the sea. I couldn't find enough information about it, so I didn't go into it. But this lake, the saltwater lake in Alaska, is affected. It doesn't have the same amount of salt in it that you have in the Utah's Great Salt Lake or the Dead Sea. So it doesn't have that amount of salt. So it's got more like the salt that's in the oceans. So that's why I think that it's probably being fed by the ocean. Because if you have too much salt, what happens is that you're not going to have not enough water. You're not going to have that same turbulence happen. You have a lot of electricity and everything going on in there, but because it's becoming more solid, that you're not going to have. It's not a solid. It's in a phase change, but you're not going to have that same effect as you get in the oceans. I see as well with the oceans, what you have is you constantly have the sun moving around them, causing the convection, whereas you don't have that constantly let's say in the lakes like Utah's Great Salt Lake or the Dead Sea, as well as the fact that it has such salinity to it. There's so much salt in it, and there's not a huge amount of water in it. So that's why if there is tidal issues there, that I couldn't find information on them for some reason. I don't know why. But if there isn't a whole lot of tidal activity there, it's because of the density of the water and the lack of water. That's what really is the problem there. Now, 12. According to Albert Einstein's theory of general relativity, neither the sun nor moon is interacting with Earth's tides in a gravitational manner. So this means that according to current science, we should not expect the sun and moon to affect our tides, as Einstein's field equations account for no more than one accumulation of matter. What that means is that in his field equations, he did not account for what people term as more than one mass. But I don't use the word mass as I have a problem with it. So we will refer to it as one accumulation of matter. So he never calculated for any more than one accumulation of matter. So there was no mass attracting mass nonsense in his theory of general relativity. So in that theory that came out in 1915, 105 years ago, when that superseded Cavendish era gravity, that took the whole idea of the sun or moon having any effect on our tides gravitationally. So there was no gravitational pull or push or anything on our tides, as any claim of gravity in mainstream science is based around Albert Einstein's theory of general relativity, which states that it's an effect on that one mass, let's just say one mass or one accumulation of matter that bends the spacetime. Okay, that's obviously there's more to it. There's more convolution than that. But the point is that he does not account in his 10 field equations. He does not account for more than one accumulation of matter. So you cannot, right? If you accept Albert Einstein's theory of general relativity, you cannot ever claim that the moon or sun is affecting our tides, as the gravitational effect on them is localized and to them only, and it does not have any interaction with any gravitational effect on the Earth, on the globe Earth. Let's just say. Not that I believe in any of that. I'm just saying this is what Albert Einstein was saying. So no, the sun and moon, according to mainstream science, current science, has no effect on our tides, and people are still being taught that in schools for whatever reason, I don't know, but it's 105 years out of date. And it's not correct anyway. It's all wrong anyway. But as we have relative density equilibrium, which explains the whole lot. But anyway, that's another issue. Okay, 13. It has not been established whether the moon is affecting our tides or not, but it is established that any interaction the moon might have is not as a result of a gravity belief. So the whole idea that the moon is affecting our tides is a load of rubbish. That's not happening. Okay, not because of gravity. It might be happening for a different reason, but nothing to do with gravity. It might be an electric reason or some other magnetic field reason. Who knows? But it's not gravity. Okay, 14. Okay, the last one. It is established that the sun does cause convection within our oceans, and convection causes movement due to a temperature exchange. So the sun is causing convection, right? It's causing movement. So you have the sun causing movement. You have the salt in the water, the sun causing movement due to the temperature changes and density changes. You have the salt in the water, okay, that's such a good conductor of electric charge. The electric charge is being created by a magnetic field. Then the moving salt water is creating an opposing magnetic field and creating that moving salt water is a moving electric charge, so it's creating an opposing electric field. So maybe we only have it's a case of we only have maybe one magnetic pole on the Earth, and the other one is up in the sky. Something I don't know, but it seems to be that that it always seems to work in tandem, right? And it's what I'm putting out here. I can show some physical demonstration of. So even if people want to say you don't know what you're talking about or this is nonsense, then please show me gravity affecting salt water. Show me how gravity doesn't affect your gravity that you believe in. Whoever has a problem with it, show me how gravity affects oceans but doesn't affect lakes, freshwater lakes. You know, because I can show with demonstration what's going on and has no connection at all to any gravity belief. So I think these three factors, magnetic field, electric charge, and convection currents, go a long way to explaining how our tides work. And basically, I see it as about 90% of the explanation. There might be a small bit more to add in, but we're very close with this. Okay, thanks for watching. I hope it was informative, and that I would like if anyone has anything to add to this, not telling me that I don't know what I'm talking about or any nonsense. If anyone has anything proper to add, then leave it in the comments. Thank you.